Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Let's see this problem. So we are given an array of numbers and our task is to find a pair or two numbers such that when we take bitwise of two numbers we get maximum number. This problem is a little bit tricky to understand. So to get better understanding of this problem, let's see few examples. So let's say this is an array. And in this array we have 5 elements 1, 2, 3, 4, 5. And when we do bitwise AND of 4 and 5, we get 4. Apart from these two numbers, if you do bitwise AND of any number like 1 and 2, 2 and 3, 1 and 4, you always get number less than 4. Let's see next example. So we have an array of 4 numbers 4, 8, 12 and 16. And if we do bitwise AND of 8 and 12, we get number that is equal to 8. So apart from these two numbers, if you take bitwise AND of any numbers, you are always going to get a number that is less than 8. So that's why the output is 8 and here output is 4. And there is one constraint in this problem, and that constraint is we cannot choose the same number. We cannot choose same number. It means I cannot take bitwise AND of 4 and 4 or 5 and 5 or 2 and 2. Okay? So this is the one constraint. So now I hope you understand this problem really well. So let's pause this video and think about an algorithm to solve this problem. So I hope you would have written at least basic program to find pair of two numbers such that when we take bitwise of AND of two numbers we get maximum number. If not, that's okay. So let's have a look at brute force approach to solve this problem. So the idea of brute force approach is really simple. We initialize a variable max to 0 and then we run a loop from 0 to n-1 to pick a number, and then we again run a loop from 0 to n-1 to find the pair of that number. So it means in first loop we are picking one number and in second loop we are finding pair of that number, means second number. Okay? And while iterating we calculate bitwise AND of both the numbers. If we find a number that is greater than max, then we simply update value of max to greater number. Okay? So this is how when loop gets completed, we get a number and that number is going to be the maximum number. Okay? Clear. So now let's see the implementation of brute force approach. So here you see a function and this function is taking ARR as input. We are initializing a variable maximum to 0 and then we are running a loop from 0 to array.length. And inside this loop, we are again running an inner loop from 0 to array.length. And there is a constraint that I should not be equal to j, means we cannot take same element or same number. That's why I have put this condition over here. If I is not equal to j, then we simply find ARRi and ARRj, means we are taking bitwise AND of both the numbers. And then we are find maximum among the current max and the new number. If we find number greater than this maximum, then we simply set the value to maximum. And after this loop, we are returning maximum value. So let's quickly do dry run of this function and see how it works. So let's say we have an array of 5 numbers 1, 2, 3, 4, 5 and the initial value of maximum variable is 0. In first iteration, our I is 0. So ARR of I is 1. And this ARR of I is going to check bitwise AND with all the numbers. And that numbers are 2, 3 and 5. When it takes bitwise AND with all the numbers, only 3 and 5 gives number that is maximum than 0. So we update the maximum to 1. In next iteration, when I becomes 1, ARR of I is equal to 2 because the first element is 2 and 1 was the 0 and 1 is the 0th element. Okay, this ARR of I checks this ARR of I takes bitwise AND with all the remaining elements, and that are 1, 3, 4 and 5. So out of all the elements, only 2 bitwise AND 3 gives maximum number, that is 2. So we update our maximum to 2. When I equal to 2, our ARR of I is equal to 3. It means the second element is 3. And it's going to find bitwise AND with other elements. And this time we get 2 if we do bitwise AND of 3 and 2. So our max remains as it is. In next iteration, our I becomes 3, ARR of I is equal to 4 and this ARR of I is going to check bitwise AND with all other remaining numbers, and that are 1, 2, 3 and 5. So this time when we do bitwise AND of 4 and 5, it gives us 4, and that is the maximum number so far. So we update our maximum variable to 4, and in next iteration when I becomes 4, ARR of I is equal to 4. It checks all the number and we are not able to find maximum number other than 4. So we keep our maximum as it is. So the maximum number is 4. So the output of this input array is 4. And how we got this 4? By doing bitwise AND of 4 and 5. It means two numbers are 4 and 5 and the output is 4. Okay, great. So now let's talk about the time complexity of this function. So it is clear that the outer loop is running n times. Inside outer loop, inner loop is also running n times. So the total time complexity comes out to be n into n. As it is a nested loop, that's why we are doing product of n and n. So it becomes n square. So the total time complexity of this algorithm is equal to theta of n square. And talking about space complexity, as we are not using any extra space or array, that's why the space complexity is only theta 1, that is constant. So far so clear. So I don't think that this is the best approach to solve this problem. I think we are doing a lot of work. We can do something better and we can solve this problem in less time. So let's see how we do it. So before I talk about efficient approach, let's analyze something. So let's say if I give you two numbers and these two numbers are by default 0. And if I give you a choice that you have to set one bit in each number, so that if I do bitwise AND of both the numbers, I get maximum number. Okay. So which bit you are going to set and which digit you will choose, 0 or 1? As we know that in binary representation of any number, each bit represents power of 2, correct? This bit represents 2 to the power 0, that is equal to 1. This bit represents 2 to the power 1, that is equal to 2, 4 and 8. So this time you have to be little bit greedy and think about how to get greater number, right? So obviously you are going to choose 2 to the power 3 because the value of this bit is maximum here. That's why you are going to choose this bit, right? And talking about digit, you are obviously going to choose 1. Why? Because you know that AND operator only gives 1 when two bits are 1. If any of the bit is 0, then obviously AND operator gives 0. And we do not need 0, we need 1 to get the greater number, right? So let's say this is a number and you set the most significant bit, that is the 4th bit. So you get 8 after taking bitwise AND of both the number. And if you would have chosen the least significant bit, then it would get 1 after doing bitwise AND of both the number. So here we can learn two things. First thing is, most significant bit is our priority because that bit gives greater number always because it represents the higher value, right? And second thing we learn here that we have to always set bit as 1 because AND operator only gives 1 when two bits are 1, right? In all other cases it always gives 0 and we are looking for 1 only. We are not interested in 0. So these are two learnings we get from this analysis. Okay. Now let's analyze OR operator. So let's say I have given you a number that is 0. And if I tell you that set second bit, then how you are going to set? So to set second bit, you have to find a number whose second bit is set and you simply perform OR operation. So after performing OR operation, you get a number whose second bit is set. So this number gets converted to this number with OR operation. Let's see next example. So let's say if I give you a number 0010 and if I tell you that give me number whose third bit is set, and if I tell you that please set the third bit of this number, then what you would do? You simply find a number whose third bit is set and you do bitwise OR of this number with this number and you do bitwise OR of both the numbers. So you get a number whose third bit is set and also second bit is set. So it keeps the already existing bit and add new bit to it. So what we are going to learn? So what we learn from OR operator that it is used to include set bits at a specific position. So when we use OR operator, we can set bits to a specific position while keeping the existing bit intact. Okay. So now let's use the knowledge of both the analysis to solve the problem. So this is the idea of efficient approach. So let's assume 4-bit numbers as of now. Although in Java, integers are stored in 32-bit representation, but just for the sake of simplicity, I am assuming that we have only 4-bit numbers. And we have this array of 5 elements, 1, 2, 3, 4, 5. And this is the binary representation of a number that shows the value of each bit. Okay. And this is the position of each bit, first, second, 3, 4, and these are the value of each bit, 1, 2, 4 and 8. So we initialize a variable response with 0. And then in first step, we are going to set 4th bit. Why 4th bit? Because 4th bit always gives greater number, because the value of 4th bit is greater among all the bit. And this number is going to be our pattern. I will explain what does it mean. Now our task is to search two numbers whose 4th bit is set, right? Because if 4th bit is set in both the numbers, it means that number is probably going to give greater number if we do bitwise AND of both the number. If we not found that number, we simply move on to next bit. And if we found that number, then we are going to simply include that bit in our result number. Okay. Now moving on to next step. Next step is now we are going to set 3rd bit, but including 4th bit, right? And then we are going to search two numbers whose both the bits are set. If we are not found that number, we simply move on. And if we found that number, we simply include that bit in our result variable. So now our result variable has 2 bits set, 4th and 3rd one. And this step we are going to repeat for all the remaining bits. And at the end, we get the maximum number. So basically what we are doing in this approach, we are forming a number. And how we are forming a number? By setting 1 bit at a time. First we are setting 4th bit and checking, do we have two numbers whose 4th bit is set? If yes, then include this bit. Then we are searching for 3rd bit. Do we have two numbers whose 3rd bit is set? If we found that number, then we simply include that bit in our result variable. So this is how we are forming a number. It means all the set bits in this number are exactly same as the two numbers present in the array, such that when we do bitwise AND of both the numbers, we get this number, and that number is going to be the maximum number. Okay, moving on. So this is the implementation of efficient approach. So what we are doing in this approach, we have a function. This function is taking array as input. We are initializing result variable with 0. And then we are running loop from 31 to 0 in reverse order. Why? Because in Java there are 32 bits in integers. Okay, so we are going to set 31st bit first, and then we move like this, and then we move on to 30th, then 29th, then 28th. Okay, in this loop we are calling a function find two numbers, and in this function we are passing an array and the pattern, and this function returns the count of numbers. And if we found two numbers, then we simply include this pattern in our result variable. Okay, and at the end we are simply returning result. Now the question is how find two number function is working. So let me show you how it is working. So this function is simply running a loop for all the element present in the array. Okay, and in each iteration this function is checking if n and pattern is equal to pattern. Okay, if this condition is true, then we are simply incrementing count by 1. Okay, let's see what this expression is doing actually. So let's say we have set 4th bit first, 1 0 0 1 0. It becomes 1 0 0. So this function is going to find two numbers whose 4th bit is set, right? And what this expression is doing, let's say you have number 8. When you do bitwise AND with this pattern, this is our pattern, right? 1 0 0 0. Then obviously we are going to get 1 0 0 0, and that is equal to pattern, right? Even though if the number is not 8, let's say number is 9, 1 0 0 1, and if we do bitwise AND with this pattern, we get the pattern back. Okay, so this is how this function is finding two elements or two numbers whose kth bit is set or not. Okay, and if we get count is greater than or equal to 2, it means two numbers are present. So we are simply including this bit in our result number. Okay, this is what it is doing. And here you can find this expression. What this expression is doing, let's say our result variable has this right now 1 0 0 0 and we are 1 0 0 0 and we are setting third bit. It means we are setting this bit. So before calling this function, it's going to perform OR operation. It's going to set this bit and then send this pattern to this function, so that now this function search for two numbers whose both the bits are set. And if the bit is not set, then we simply ignore, because we are checking here that if count is greater than or equal to 2, then only we are including this bit in our result variable. Okay, so this is how this function is working. So let's do a quick dry run of this function and see how it works. So let's say we have an array of numbers 3 4 5. In first iteration our I is 4, so I am not considering 32 bits here. I am only considering 4-bit numbers. So in first iteration our I becomes 4. We are going to set fourth bit and we are going to check all the numbers whose fourth bit is set. So here there is no number whose fourth bit is set. So we simply continue to next iteration. In next iteration of I becomes 3. So the pattern is going to be 0 1 0 0. Now we are going to search two numbers whose third bit is set, and we fortunately found two numbers whose fourth bit is set. So we are going to include this bit in our result. So now our result becomes 0 1 0 0. So in next iteration our I becomes 2. So in this iteration we are setting second bit, and because of the OR operation we are doing here, we are including second bit as well as third bit. And then we search, is there any two numbers whose second and third bit is set? So this time we do not find any number. So we continue to next iteration. In this iteration our I becomes 1, and this time we are going to search two numbers whose third and first bit are set. And this time also we are also not able to find whose first and third bit is set. So our loop gets end and we get output as 4, because this binary representation is equivalent to 4 in decimal. Okay, clear. So this is how this function works. So let's see the time complexity of this function. So how many times loop is running? So in our case loop is running 32 times. And how many times pattern loop is running? It is running n times, and n is what? Number of elements present in the array. So here I am representing 32 as log of m. Why? Because in worst case, if you get a larger number, it means you got larger number in an array, and that number is also largest in the integer. So if you consider largest integer, you see that your most significant bit is going to be set, right? And if you take log of that number, then you get number of bits required to represent that number. So in worst case, you get largest number. It means all the bits are set. And if you take log of that number, you will find number of bits used to represent that number. So that is why I am writing 32 as log of m. And for each iteration, we are running a loop, pattern loop for n times. So that is why the overall time complexity of this function comes out to be big of log of n into n. And what about space complexity? As we are not using any auxiliary space or array, that's why the space complexity of this algorithm comes out to be theta of 1, that is constant space. So far so clear. So before we end this video, let's have a quick recap of what we have done so far. So we are given an array of numbers and we have to find a pair such that when we do bitwise AND of both the numbers, we get maximum number, and we have to find maximum number. To solve this problem, we saw the brute force approach first, and in that approach the time complexity came out to be theta of n square, and that is a quadratic order of growth. Next, we saw the efficient approach to solve this problem. In this approach, we are using a pattern, and by using that pattern, we were searching two numbers such that when we take bitwise AND of both the numbers, we get maximum number. And the time complexity of this approach came out to be big O of log of m into n, where n is the number of elements present in an array and n is the maximum number in an array. So this is it for this video. Thanks for watching. See you in the next video.